Good afternoon, everyone. I welcome to this session on, we're going to cover through a fintech case study using Apache Ranger, Atlas, and Privacera. Quick show of hands, how many of you guys are running Ranger and Atlas today? And how many of you don't know anything about Ranger and Atlas? Okay, so we got quite a few. Okay, so we'll make sure we'll touch upon the introduction, but we'll go through a case study on a journey of a fintech company and how they started with Hadoop, how they implemented some of the security imperatives using some of the Ranger Atlas features, as well as Privacera, which is where I belong to. So let me start quickly with an introduction, then I will cover through the agenda part. My name is Balaji Ganesan. I'm CEO of a startup called Privacera. We are a Hortonworks partner. We focus on security and compliance within data lakes. So I'll go through what we do in the next few slides. But before that, let me introduce you to Alberto Romero. Alberto?
Yeah, hi, I'm Alberto Romero, Big Data Architect at G Research.
All right, thanks. So it's exciting stuff coming that Alberto is going to talk through. So what we're going to do through is we're going to go from a higher level. So we're going to go through what is happening in big data. It's primarily from our observations. What are the challenges companies are having? What do we see as recommendations? Then we'll drill down into an actual case study. So you will see an actual implementation of that, how that's been used. And we'll go through some of the Apache Ranger, Atlas, as well as the Privacera, where it fits into the architecture. And we'll kind of wrap up, Alberto will wrap up based on the learnings and challenges, and then we'll open it up for questions, okay? Great. So quickly about Privacera, which is where I belong to. This is a startup based in the Bay Area. We primarily operate in the data lake and the big data environments and partners with all the distributions. Our core focus is helping identify what we call as sensitive data, which could be personal data, PII, PCI, PHI, confidential, restricted information, being able to do that and help you control it. So we do 4 primary things in this environment. We have an automated discovery and classification mechanism, which uses rules as well as machine learning to go through files or tables of structured, unstructured data and really identify PII, PHI, PCI, sensitive information, tag and classify that, and we push that to Atlas and Ranger in Hortonworks environments. And so the goal is to find out where your sensitive data is, and we'll help you answer that. Then we take that information and help you controlling it, which includes access control in terms of ensuring how users get access to it. And that's some of the things we will talk using Ranger, how it can be achieved. Again, driven primarily using data classification. The other thing we do is anonymizing data on ingest or in the lake, and we anonymize by preserving formats. We can tokenize information, or we can mask or redact that information. But by doing that, we help companies build data lakes and can run analytics using the anonymized data. And we have plugins on the consumption layer to give access to any user who would need access to the clear data. So it's a very intuitive way of doing that. And finally, monitoring. In terms of how users can use data, we monitor and mine through the access history to find out what are they doing and bring analytics and reports around that and some of the alerting in case of inappropriate access. So that's a nutshell of what we do, and we primarily focus on addressing some of the challenges, which is what we will also talk about in this case study. But we continue to see in big data environments, whether it's big or small, have some fundamental challenges on how they have, which is your high volume, velocity, and variety, which characterizes big data. But it's also driven by a lot of stringent security and now privacy requirements, whether it's GDPR in Europe or other requirements coming up in other states or other regions of the world. And so if you're building data as a service, if you're building multi-tenant environment, whether it's a self-service environment or user-driven environment, where a lot of users are interacting with the data, that presents some fundamental challenges that you would need to think about. And users have multiple tools to access data. They can use Spark, they can use Hive, And from a security and a governance point of view, how do you ensure the same experience and the same security and capabilities are ensured across all tools? It continues to be a challenge. And what I continue to also see is that the tools that exist in the market today have come from a traditional database world, and big data presents fundamentally different challenges. And those are some of the things we are trying to address. And what we usually recommend is a 4-step layer, and we will delve into that in the case study, is really understanding, you essentially implementing these 4 steps. You will have a consistent behavior, and you can address some of the security and compliance challenges irrespective of which kind of data lakes you have, whether you're on-premise or in cloud. And that involves, first step is investing in understanding your data and understanding part of your data, what are your restricted confidential information or sensitive information or personal data, and doing it in an automated way, which is scalable. Using that information to build your policies, build your access control policies on what users can get to data. So irrespective of where data is, they have a consistent same policy of access. Also thinking about anonymizing data that opens up use cases, whether you want to do it in the cloud or whether you want to onboard more data, and anonymizing in a way that you can use data for analytics. So preserving formats, tokenizing, and other aspects. And then finally monitoring. Once you have done these steps, you have a mechanism to verify what users are doing in the system. And having an automated way to create alerts in case there is an inappropriate access or malicious movement of data. So having those steps, and this is part of a blog that is in Hortonworks website as well, having these steps gives you more comprehensive strategy, right? So that's the high level. What is happening in big data? What can you do to address that? Now what we're going to do is go into a very specific case study, and what Alberto is going to walk through is, from G Research, what have they done to address some of the challenges in the context of their business scenario, but using some of these steps that I've just talked about. So with that, over to Alberto.
Thanks, Balaji. Yeah, and just to echo Balaji, thanks everyone for joining the session. I'm very happy to be here to be able to share some of the insights of our journey in big data. So I joined G Research back at the beginning of last year as big data architect, with I guess the main purpose of helping to build the data lake platform for the business. So what is G Research? So we are mainly a tech company that uses technology to do quantitative research. And we do that through statistical analysis and big data pipelines. So this is oriented to the financial markets. So what we attempt to do is to recognize patterns and extract insights from the various different markets that we study. And by doing that, we have to leverage a lot of data from these markets. We have to leverage sometimes complex pipelines. And this approach is often referred to as forecasting analytics. Because it helps us forecasting what the variances on those financial markets will be. So our clients typically will consume that data on our services, our platform, to then operate on capital markets around the globe. As a company, we are currently undergoing a very aggressive growth. So we are expanding our various teams. Anyone related to big data in particular. And we also in the process of adopting the latest and greatest cutting edge technology. So you can probably tell that we really like our data. So we are we're very much a data-driven business because it is inherent to what we do. So I wanted to walk through a little bit of some of the data sets that we typically deal with. So probably the most obvious one is market data, which can typically come in two forms. And any finance guru in the audience will have to forgive me for oversimplifying things. This is literally just to set the background for what we do. So essentially, it can come in either level 1 data, which is often referred to as top-of-the-book data, which is just basic market data. This market data is essentially instruments, bid prices, ask prices, and then volumes for either. In terms of the second type of market data that we can have is level 2 market data, which is a lot richer. Because we not only get what we get with level 1, we also get 5, 10, or 15 different positions in the market that are not necessarily the highest bid or the lowest ask, but also the subsequent following ones. So, just to probably make it a little bit more graphical. So, when you are in a market and you have a bid which is at a certain price and an ask that is a certain price, normally is the highest bid and the lowest ask. When they match, you get an operation executed. So that's typically that's just the top of the book level 1 data. When we talk about level 2 or market depth, is essentially changes on the market every nanosecond. So just imagine every nanosecond there are positions on all these markets changing, not necessarily changing the highest bid or the lowest ask, but changing subsequent positions from different bidders or askers that have an impact on the market. So obviously this is a huge data set, and it's also hard to represent as well because it's typically a stream of incremental updates, as I said, with nanosecond granularity. Other data sets also include things like data packs for additional enrichment. We also do risk analysis on positions and portfolios, strategies, etc. We use reference data from markets, which is a bit like metadata from markets. So tells us about the market structures, corporate entities, and things like that. And obviously, we also ingest news feeds. I'm not going to mention anyone in particular, but I'm pretty sure you can all think of at least a couple of them that are quite known. So what are the reasons for us to turn over to Hadoop as a platform to scale with? So first of all, as you've already seen, we do have a lot of data to deal with. And this data comes from various different formats, because it comes from various different sources. And sometimes we need to process the data in a very fast manner, so that we can deliver the data to the right subsequent pipelines and so on, and obviously make the insights as relevant as possible. The platform would also need to be multi-tenant, because there are various divisions in the company that tackle different things that we want to do research on. And we would also need the flexibility to adapt the platform to our needs. So that's basically how you typically describe a Hadoop data platform. So it's a perfect match. I mentioned earlier we are a very tech-focused company. These are some of the technologies that we currently use. You can see they are across different verticals. So obviously we use Hadoop, but in terms of processing, we use Spark. We also leverage NiFi to some degree, with other things like Storm coming up as well. We use data stores such as Cassandra or HBase or Hive to persist data and be able to have a different view of the data. And then we, for our own services, we spin up Docker containers in Kubernetes, and this is something that we're starting to do now, so that we can provide with additional data services alongside the data platform. So when I first joined the company, there were a few major requirements, and interestingly enough, the first one was security. So security is really key in the company because we need to protect our intellectual property. So you can obviously understand why we would want to do that for data, but in some cases for us it's even more important to protect our code, because that's basically what differentiates us from the competition. Then we also need to do the integration with existing systems and processes. So in the case of security, we already have authentication, some encryption policies, and be able to have some authorization as well. Then the third requirement would be multi-tenancy and scalability. I mentioned earlier we have different divisions. Within development, we have lots of different development groups, and they all work on the platform. They all work on their use cases, and they all want a share of the platform. And in terms of scalability, we are, as I said, experiencing data growth explosion because of all the market data and other types of data that we have to deal with. And last but not least important is governance. So we need to enable people in ways that they can find data easily, they can collaborate between each other, and then allow for new use cases and allow them to be able to do other things as well. And then at the same time, we also need to be able to track data changes, be on top of how we change code, and maintain consistency across. You're probably sick of hearing the quote, "Data is the new oil." I doubt anyone here has not ever heard this phrase. Someone has probably been quoted a billion times, or if not more. One thing I'd suggest is moving on to a new paradigm, which is metadata is the new data. Because unless you know what to do with your data, where your data is located, what your data looks like, you can't really make use of it. Even if you have a lot of it, you can't really do a lot. If you use a transitive property of equality, then you could end up with metadata is the new oil. So, which is a nice phrase as well. So in the solution design, basically at high level we want to do 4 steps. So this is what we want to achieve. We want to ingest data in various formats. Then we have those data sources added to AGP. We then transform them or pre-process them so that we can do some further processing later on, and at that point we want to be able to classify the data appropriately so that it can be used later on, and it can be explored, and it can be searched on later on. So this is the foundation. For those of you who raised your hands in terms of not having any experience with Ranger, or Atlas even. Ranger is the component that provides us with authorization and auditing capabilities. This comes out of the box if you have AGP. If you use strong authentication or security, you use Kerberos, and then in our case, we also encrypt data on HDFS. So all of this is quite standard. Many people do this already, so it's nothing too fancy. But this is probably a little bit more custom to what we do. We started doing data discovery, for which we use both Privacera and Atlas. We have also implemented our own Spark lineage. Because sadly enough, and for those of you who have already used Atlas before, there's no such thing as Spark lineage out of the box, at least today. So Atlas is great. It's a very good framework, but it's not really a finished product as such. You have to build on top of it. So in our case, we built in terms of Spark lineage that enabled us to do Ranger tag-based policies, which means that we don't really care much about the actual resources or permissioning on a per resource basis. We don't mind if a type of data, say position data, is a file or is a Hive table or a Hive column in a Hive table. We just care about the actual data that is there and the representation of the data. So if you are able to tag your data appropriately, then you can permission based on how you tag it. And then we're moving on to doing things like dynamic masking on Ranger based on who is making the query, and then some monitoring as well with Privacera, which we'll get into just in a minute. This is our very high-level architecture. It's probably very similar to the ones that you probably have. So we have our users, developers, researchers, etc. That use edge services to access data services on the platform. We use the likes of Kafka and NiFi, and as I said earlier, we use Docker containers to basically spin up microservices that then access the data platform. I guess what is different to maybe other setups is the fact that we capture as much metadata as we can. You get out of the box high metadata with Atlas, but we also do, for example, ACFS data discovery by using Privacera. So as data lands on your ACFS, then we are able to discover it, tag it based on certain rules, and then we push that into Atlas automatically. And then obviously, as I mentioned earlier, we leverage our own Spark lineage. So in terms of exactly that, the metadata in Atlas, if you want to start defining your models in Atlas, you need to do a meta model definition. So if you think of Atlas, for those of you who are not very familiar with it, you basically have two things. One is a type, and another one is an entity. A type is a definition of something, almost like a schema. An entity is the actual object, is an instance of that type. So if you think of object-oriented programming terms, a type is a bit like a class, and an entity is a bit like an object. So we defined our Spark job type. Say, for example, we are running a Spark job, then that gets instantiated. That entity will have attributes like ID, operations. For example, if the job has got or is doing a join, or is doing other types of operations, and then it's got input and output data. Each of those at the same time can be instances of types that we also define in our meta model. So, for example, we define our Spark join operation type or our Spark dataset type. And when you run the job, what you get is a lineage of instances of different types that all relate to each other. And then each of those types can at the same time extend, again in object-oriented terms, extend from other more generic types. And those types may already be defined in Atlas, such as the type process or the type dataset, etc. So it's just inheriting attributes from those other types. So if anyone is interested in going more into detail on this, we can have a chat later on. Just let me know. So what has our journey in data security been like? So I'll start from the bottom. So we started implementing the platform just with your standard Ranger policies, which are very simple. You have a resource, say an ACFS path, a Hive table, and you allocate permissions to a user or a group. To then move on to more complex stack-based policies, but based on what you get out of the box with Atlas. So typically Hive-related data. And And then we got into something a bit more complex and more flexible by introducing our own Atlas meta models and by introducing Privacera. Because we were able to then capture a lot more metadata and create a lot more tags, have our data tagged in a much more precise manner, with the objective of allocating permissions based on those tags, rather than having to define a new Ranger policy every time someone creates a resource, a path on HDFS, or a Hive table, or an HBase table. We only care about what data is in those resources, and then we permission them based on those tags. And then the last step is advanced security policies based on data zone definitions, which we'll go into more detail now. So in Privacera, you can define your data zones, which are basically is a different abstraction from the actual HDFS or any resources in Hadoop. So you can, to a data zone, you can add, say, a set of tables or a set of HDFS paths. You add them all together and you call it a specific data zone. So for example, you can have a public data zone and a restricted data zone. So your more sensitive data cannot be on the public data zone. So how is this important? It is important because maybe someone who's got legitimate access to sensitive data then ends up reading that data and then writing it on the temp directory on HDFS, or writing it on his user folder on HDFS, which is not as restricted, doesn't have the same level of restriction as the previous data zone. So that's the sort of thing we want to alert on. So Privacera currently alerts on those data movements, and I think it's in the roadmap to also prevent those data movements to actually happen, which is exactly where we want to be. Now moving on to the last bit, key challenges and learnings. Basically, there are two types: technical challenges when scaling our metadata solution. GraphDB isn't always the best tool to use. At one point, we had hundreds of thousands of entities that were being tagged every week, which isn't great to scale with a graph database. So the guys at Privacera rewrote the backend so that it would use HBase and Solar exclusively, and we saw a significant improvement. We also reduced the number of entities tagged per week, so that we would only go down to the level of granularity that we were interested in. Not necessarily tag every single file that lands on HDFS, but everything that was relevant. And then the second technical challenge was open source flexibility, which is often seen as a two-sided coin. Because it is very flexible, you can adapt it to your own needs, but then at the same time, you are sometimes a little bit on your own, doing integration between components. Each Apache project is a different project, is written by different people, and that integration can sometimes be a bit of a challenge, but it's an interesting journey to be on. And then a business challenge, which is perform process integration within the business. So there are already lots of processes, and you want to enforce governance, or you want to enforce a more advanced security model. So sometimes it can be hard to push forward those changes. Right, so I'll let Balaji go through the summary.
Thank you. Thank you, Alberto. G-Research is an incredible company. Alberto is awesome, and I would encourage all of you thinking or starting in the data lake journey to connect with Alberto, and there's Thibaut from G-Research team. Incredible team, incredible work they have done in the short span, and there's amount of learnings they have. You can tap into that. And so let me wrap up, and based on summarize, what we learned today. is that at different stages of the journey, you will have different challenges. If you're just starting, you can start with the basic foundations of security, but as you onboard more users, as you become multi-tenant, as you onboard more data, you'll have to think beyond certain challenges. So you'll have to think about understanding data, understand discovery, do tagging, and using Atlas as the metadata store. But once you have tagged the data, then you can start building policies based on the classification. So instead of just table being allowed to one admin, they can be allowed admin to a set of data and a classification base. So that's where you can start leveraging some of the tag-based rules in Ranger. And you can start also thinking about how to anonymize data on exposure or all anonymized data at rest, because that opens up for more further use cases for your data lake, whether it's on-premise or whether you're putting this subset of that in the cloud. And so you can always look at anonymization as a great tool in addition to your basic security foundation to enable whether it's GDPR or whether any other use cases on security. And then finally, look at monitoring. So you have, again, these are, if you have a set of users that are coming in a multi-tenant way, you may want to have build a mechanism to say, what are users putting data in? And because big data provides you a lot of mechanisms, but you need to have a mechanism to trust but verify. So you want to allow use cases, but you also want to get visibility. So having those steps will give you more comfort to handle imperatives from your security team as well as your governance and privacy teams, okay? So with that, again, connect with G Research after this session, and I think they will be able to tell you more. Alberto is an awesome guy. You should always connect with them. With G Research is hiring, so are we. So if any of you are interested, we're happy to have an extended conversation with you. So I think we got about 10 minutes or so. We can open up for questions. Yes, in the back. Is there a mic? Sorry, is there? Okay, all right. Mm-hmm. Got it. Got it. I think, so I'll repeat the question, but I think Alberto is the right guy. So I think the question was, I think we talked about understanding the context and building security based on the classification, but there could be use cases, if I understood that correctly, is the data set individually will have medium or low security, but the combination of those data assets could become a high security. So how do you build security around that? Did I understand the question correctly? Okay.
And is a brilliant first question because it's something we also care about. This is really, really important. So we need to be able to capture the logic behind what combination of data assets produces what levels of, I suppose, security in terms of you protecting your data. So that is something that you can define through rules. You can make those rules more or less basic, more or less into detail as to by either naming specific combinations of data types that should never be aggregated unless they get a specific security tag. That is something that to some degree we've started doing. So we can we can already do some basic tagging based on certain basic rules, but it's a very valid point. Yeah.
Yeah, I'd like to add that basic out-of-the-box Ranger does support, if you can flag two columns in the table and they say it should not be never in the query together. But it goes beyond I think what you're indicating is what we see is goes beyond just two columns in the table. It's the combination which needs to be identified. So credit card and CVV as an example, or an address and a PIN code, for example. could lead to more details than just the street name or the street address. So there are certain toxic combinations that can be pre-identified, and then you will have rules within the enforcement engine to prevent somebody from running a query. So that is possible in a way today, but there is some work, as Alberto said, to identify those toxic combinations beforehand. Any other questions? Good. So appreciate everybody coming in. Thank you so much. We'll give back 5 minutes of your time, but thank you so much for coming in. We'll be here for a few minutes if you want to have any additional questions, but thank you, everybody. Thank you, Albert.
Thank you.